Greetings everyone, I welcome you all to TV Math Hub. Today we want to look at an expression which is involving trigonometric ratios, and the expression says 3 sine of x plus 4 cos of x is equal to 2, and we need to solve this for values of x that lie between negative 180 degrees and 180 degrees, for which negative 180 degrees and 180 degrees are inclusive. So let us see how best we can solve such an equation. We shall look at two approaches, and the first approach we shall be to express the left hand side in terms of r sine of x plus alpha. So this is our left hand side. Our left hand side is 3 sine of x plus 4 cos of x. We shall try to reduce this to be in form of r sine of x plus alpha. So let us look at that. If we express 3 sine of x plus 4 cos of x in terms of this, so we shall need now to expand sine of x plus alpha. Then we equate the coefficients on both sides. So let us look at that. We know by sine expansion, if you have sine of a plus b, this is same as sine of a cos of b plus sine of b cos of a. So using this expansion from compound angles, we shall have to express r sine of x plus alpha to be r sine of x cos of alpha plus r sine of alpha cos of x, and this is equal to 3 sine x plus 4 cos of x. So from there we shall try to get the coefficients of sine x here and this side. So the coefficient of sine x this side is r cos of alpha, because when you try to rearrange this, you have r cos alpha sine of x plus r sine of alpha, then here it is cos of x. So you are equating this to 3 sine of x plus 4 cos of x. So what does that one imply? For this expression to be equal to this, it means the coefficients of sine x here and the coefficients of cos x on both sides must also be equal. So for that case, when you compare the coefficients of sine x and cos x on both sides, you will have r cos of alpha equaling to what is the coefficient of sine x this side is 3. So you have r cos alpha equaling to 3, and when you look at the coefficient of cos on both sides, then this side, on the left hand side, we have r sine of alpha, then on the right hand side we have a 4. So you have r sine alpha equaling to 4 and r cos alpha equaling to 3. So after comparing the coefficients of sine x and cos of x, then we come up with r cos of alpha equaling to that and r sine of alpha equaling to that. So our interest will be to get r and to get the value of alpha. So looking at the two expressions that we have got here, we can be in position to get the value of r and to get the value of alpha. So we shall square. If this is our equation 1 and this is our equation 2, when you get 1 squared, you add there 2 squared. What shall we get? So this will be same as r cos of alpha, you are squaring this, plus r sine of alpha, you are also squaring this. Then this will be same as the coefficient for the value for this, for r cos of alpha is 3, so it's same as 3 squared plus 4 squared. So looking at this, you realize you will have r which is common, r squared. Then cos squared alpha plus sin squared alpha, which is equal to 25. So this one here will give us 1, meaning that r squared is same as 25. And this will give you your r as 5. So from there, we have got the value of r, and we can now get the value of alpha. So to get the value of alpha, we shall get equation 2, and then we divide it by equation 1. So you are having r sine of alpha divided by r cos of alpha, which is same as 4 divided by 3. So looking at this, sine alpha divided by cos alpha, that will be tan of alpha. So tan alpha is 4 by 3, and alpha will be tan inverse of 4 by 3, which is approximately equal to 53.1 degrees. So from there, what do you realize? We realize that we have got the value of r, and we have got the value of alpha. So for that matter, we shall try to rearrange this. So where we have 3 sine of x plus 4 cos of x, we shall substitute it with this reduced form, which is r sine of x plus alpha, meaning that this 3 sine x plus 4 cos x is same as 5 sine of x plus alpha 53.13 degrees. So it means our left hand side has been reduced to this. So when we look at our expression, when we look at the expression that we have, the expression is 3 sine of x plus 4 cos of x, which is equal to 2. And as we have seen, we have said that the whole of this has been reduced to 5 sine of x plus 53.13 degrees. So which means that where there is this, we can put there what? We can put there 2. So this will be equal to 2. And for that case, we shall have 5 sine of x plus 53.1 degrees equaling to 2. When you divide through, it means you have sine of x plus 53.13 degrees, which is equal to 2 upon 5. So it means your x plus 53.13 degrees will actually be sine inverse of 2 divided by 5. So you will be able to get your x plus 53.13 degrees, which is equal to, so you take the sine inverse of 2 divided by 5. So when you take sine inverse of 2 divided by 5, you will be able to get 23. So this will be 23.58 degrees. So we need the values of x that satisfy the range. The range that was given, is negative 180 degrees less than x less than 180 degrees. So for that case, it will imply that you need an expression that will satisfy x plus 53.13 degrees. So we must create the range for this one here. So to create the range for this, we shall say that for the given range, which is minus 180 degrees less than or equal to x less than or equal to 180 degrees, if you need the range of x plus 53.13, so you will try to create this one plus 53.13 degrees. So you do the same on each side, 13 degrees plus 53.13 degrees. So it means the given range for x plus 53.13 will be negative 180, adding there 53.13. So that will be the given range will be -1, 26.87 degrees, less than or equal to x plus 53.13 degrees, less than or equal to 233.13 degrees. So this will be the range for x plus 53.13 degrees. That will give you the value of x, which satisfies the range of -180 degrees less than or equal to 180 degrees. So we need the value of x plus 53.13 degrees in this range here. So how do we achieve that? If you draw your quadrants, you need to allocate this value here, which is 23.58 in the quadrants where sign is positive. When we look at this, sign is positive. Sign is positive in the first quadrant and the second quadrant. So in the first quadrant, allocate your 23.58 degrees. Here allocate 53.23.58 degrees. So if that is the case, then we can obtain the angles, the required angles in this range. So the first angle will be this. So it means your x plus 53.13 degrees will be same as the first angle, 23.58 degrees. And the next angle is from here up to this given point, which is same as 180 degrees. 180 degrees minus 23.58 degrees. So when you get 180 degrees minus 23.58 degrees, from here up, from this point up to here is 180 degrees. So if I need the angle from here to here, I get 180. I subtract 23.58. So that will give us 156.42 degrees. So what are their corresponding negative angles? The corresponding negative angles, the first corresponding negative angle for 156.52 will be this angle from here up to this given point. The next corresponding negative angle will be from that given point up to this given point. But what do we realize? Remember, these angles here correspond to x plus 53.13 degrees. So when we look at the range for x plus 53.13 degrees, any angle above this and this one here will not qualify. So you realize these ones here are within the same range, but when you take the negative angles from here up to here, it will be same as negative of 180 degrees plus 23.58 degrees. This will be the first negative angle, which corresponds to this angle here from here up to this given point. So this angle will be exceeding this way. Likewise, when you consider the negative angle from here up to this given point, which is same as negative of 360 minus 23.58 degrees, this angle will also be exceeding the range for x plus 53.13 degrees. So these angles will be ignored. So we need now to get the values of x, for which we have x plus 53.13 equaling to this and equaling to that. So let us obtain the values of x that lie within that given range. So for that case, we shall try to bring this one on this side. So the first angle will be 23.58 degrees minus 53.13 degrees, and the next will be 156.42 degrees minus 53.13 degrees, and respectively you will be able to get these values of x. So that is basically how we solve such an expression. So we need to look at some alternative methods. So for the person who has not used the 𝑅sin of x plus alpha, someone can also use the cos expression. But when you use the cos expression, so it means you can first rearrange this expression to be 4 cos of x plus 3 sine of x, which means you can let this to be in form of r cos of. So since this is cos, I will use cos, but to get an expansion of cos that will give me plus here, so I will use x minus alpha. So when you let this left hand side here to be equal to this, you will also be in position to get the value of r, to get the value of alpha, and then they will help you to obtain the required values of x. So this one can also work if you don't use this expression. You can use that and you will be in position to get the correct answer. Let us look at another approach. We look at an alternative method, and for this case we shall be letting t to be equal to tan a half of x. If that one happens, you should be able to easily know that if t is tan a half of x, then sine of x will be 2t upon 1 plus t squared. You should be able to prove that. And cos of x will be 1 minus t squared upon 1 plus t squared. You should be able to easily come up with this, because you know if tan a half of x is equal to t, this is same as t upon 1. So when you come back to your triangle here, and if this is a half of x, then the tan is opposite over adjacent. So you have t upon 1. So this one here will be 1 plus t squared. So from here you will be able to get sine a half of x, which is t upon the square root of 1 plus t squared. You will be in position to get cos a half of x, which is 1 upon the square root of 1 plus t squared. So you should be able now to come up with sine of x, where you can use 2 sine a half of x, cos a half of x. So substitute for this. You can come up with cos of x by using the expression either 2 cos squared a half of x minus 1, or else you can use 1 minus 2 as sine squared a half of x. Any of these, when you substitute for these values, you should be able to show that sine of x is this and cos of x is that. So looking at the given expression, which was 3 sine of x plus 4 cos of x equaling to 2, so we shall substitute for sine of x and cos of x using these expressions. So for that case, we shall be able to put where sine x is by this, where cos x is by this, and this will be equal to 2. So try to simplify, multiply through by the common LCM, which is 1 plus t squared. So when you multiply it here, when you multiply it at this given point, you multiply it at this given point, and also at this given point, you will be in position to remain with 3 times 2t, which is 6t. Then this and this will cancel. You remain with 4, then minus 4t squared. Then you multiply 2 into 1 plus t squared. You get 2 plus 2t squared. So try to rearrange this, bring everything that side. 4t squared plus 2t squared, 6t squared, then minus 6t when 6 goes that side, then 2 minus 4 will give you minus 2. So likewise, when you try to simplify, you will get 3t squared minus 3t minus 1, which is equal to 0. Solve this expression, you'll be able to get these values for t. So, but we know that t is tan a half of x. So if we get our t equaling to that, or t equaling to that, then it means tan a half of x is equal to this, or tan half of x is equal to that. So if you have tan of a half of x equaling to this, it means a half of x is same as tan inverse of 1.2636. So which means your x is 2 tan inverse of 1.263638. So from there, it means you can easily get the value of x, get this from the calculator, multiply by 2, and you will be able to get the required answer. Then likewise do the same for this. So tan half of x is equal to negative 0.2638. So likewise substitute and you should be in position to get the values of x. So you realize in both cases you'll be able to get 103.29 and negative 29.55. So those will be the required values of x. So those are the actually three alternative methods of how best you can solve expressions involving trigonometric ratios, especially where you have deep cases like sine of an angle is followed by cos of an angle. Then no matter the coefficients that you will be having here, but so long as the angles are the same for sine and cos, then you can easily use the R expression or R form, and you can also easily use the T substitution. So those are the different cases that we can use to solve such expressions. So that is where we shall stop. Please don't forget to subscribe, to like and share.
Yeah.